Hello, everyone. Thanks again for joining us today for our next interview in the Women in STEM speaker series. Each Wednesday through September 30th, we're going to introduce you to some inspiring female role models who are doing incredible work in a variety of STEM fields. This series is supported by the Association of Science and Technology Centers and If Then through a gender equity grant, which supports projects aimed at increasing the representation of women and gender minorities in STEM. My name is Caitlin Zurcher. I'm with the marketing team at Carnegie Science Center. And today I'm very excited to talk to Dr. Sandhya Rao, professor of astrophysics at the University of Pittsburgh. Thanks so much for joining us today.
Well, you're welcome. It's such a pleasure and honor to be with you. I'm really excited for this conversation.
Awesome, me too. Now I have a few questions prepared to help us get our conversation started, but for the folks that are watching live, you can absolutely ask questions of your own. Just leave them in the comments and we'll check them later and try to answer them after my prepared questions. But just first to start off, could you tell us a bit about your background, what you studied in school and how you got into the career that you're in today?
Yeah, sure. Ever since I was a kid, I was interested in nature. I was curious about things around me. And I was fortunate because my dad is a retired scientist in India. And he worked at the Tata Institute of Fundamental Research, which is in Mumbai. And so I was surrounded by science growing up. That's where I grew up. I spent the first 20 years of my life in Mumbai. And I was fascinated by the sky. I would, look for planets to show up. I had a pair of binoculars. I would look at Jupiter. And we also did things in nature, like looking for bugs, putting cinch bugs in a little shoebox and seeing them grow, watching birds. So my childhood was filled with exciting things about nature around me. It was just a question of curiosity. And then, when you get to school and you start to enjoy subjects like math and science and later on physics, which is what you need to do astrophysics. I was good at it and I enjoyed it. And so that's what led me to like a line of inquiry, right? And I decided pretty much in high school that I wanted to do research in astronomy. And so once I graduated, college in India, I moved to the U.S., where I applied for, graduate studies. I was at the University of Toledo in Ohio, where I got my master's in physics and astronomy, and then came to Pitt, actually, and I got my PhD here. So Pitt has been, great for me for the past few decades. And I started out as a student, and now I'm research professor. So it's been a long journey, but it's been really exciting, and to be involved with teaching students as well as doing research in exciting things like galaxy evolution and quasars and so on. It's been fun.
Awesome. Could you explain a bit more about how you balance that? You're a teacher, but then you're also conducting your own research. So what does a typical day or week look like for
Sure.
you?
So it really depends on the focus of that particular day or even the focus of that particular semester. And so as an astronomer, you might think that we're always at telescopes, looking at things at galaxies or stars or whatever. But astronomy nowadays is very data intensive. And so, 20 years ago, I would go to a telescope like the ones in Hawaii or the ones in Arizona to gather data for the galaxies that I wanted to study. And, so we'd go there for a few nights a semester and gather data on, big tapes that they used to be in those days and bring them to my office and work on them on the computer. So it's not like I would be at the telescope every day, right? So a large part of my work is actually analyzing data and trying to understand what those data are trying to tell us. But nowadays, the data that we get are, for example, the data that I get are from the Hubble Space Telescope. And so over the past many years, I've been using the Hubble Space Telescope for my work. And for that, of course, you can't go into space, right? So the data come to the Space Telescope Science Institute, which is in Baltimore, and we can download the data and work on projects in that way. So that's what I've been doing as far as research is concerned. But teaching, So if I have a class today, I'd be preparing for it for the past, few days, like what I'm going to put in my lecture, what kinds of new things I'm going to teach the students, prepare for exams. So there's a lot of work that goes into preparing for a teaching class. So I would say that a typical day would be teaching, if that's the day I'm teaching. And if I'm not teaching that day, I would be working on some research projects. Again, it's all on my computer, of course. Yeah, and as a researcher, you have time to yourself. It's not like you have a 9-to-5 job, right? It's something that you can do any time of the day. So it's yeah, that offers you some flexibility.
Absolutely. So with the students you teach, are they, mostly freshmen, or are they a bit more along in their academic career and know that that's the field they want to go into, or are they still kind of exploring?
So the courses I'm currently teaching are gen ed classes. So they are intro astronomy, and I'm also teaching an intro physics class. But I would say about half to 2/3 of the students are freshmen, but students, from freshman to senior take it because the university wants students to be well-rounded. They have them take gen ed classes. And so, you can take those classes at any time in your undergraduate career, but it's an introductory course. So it introduces them to all topics in astronomy.
Do you ever find that that sort of introduction serves as like this moment for students that then want to go into astronomy or physics?
Oh my gosh, yes. I mean, there are students who come in wanting to be an engineer or wanting to be a biology major or a history major, and they take the class. And of course, astronomy is something that inspires awe in everybody, right? And for a person who just looks at the sky, there's a certain amount of information that you have about planets or stars, but then to look at stars in more detail, how they live, how they explode, or how galaxies form, and so on, that brings in much more information for them to process and to start thinking about. And I've had many students who come to me and say, I really liked your class. I'm thinking of switching majors. And so that's very gratifying, right? And to be able to inspire students to actually start thinking about a career in astronomy. So yeah, there have been several cases, but they didn't really know that they enjoyed this and they liked it and that they were good at it, but that they would switch majors after classes like mine. So yeah, that has happened, and that's great.
That's awesome. Could you talk about any sort of like research projects that you're working on currently and just talk a little bit about those?
Oh, sure. So there are a couple of things that I've been involved with over the past 20 years or so, and that is to understand how galaxies have evolved, from many billions of years ago to today. We're all interested in, how we came about, right? And so that is the basic question that we ask, and you can go into different, different lines to answer that particular question. And the question that I asked was, how did like our galaxies like ours form? And ours is a Milky Way, it's a spiral galaxy. It has a spinning disk of gas and stars. So where did all those stars come from? Where did the gas come from? And so for that, you can study objects which are called quasars, which are these superluminous galaxies that are very far away. And they are powered by supermassive black holes. And what that does is, because a black hole is so massive, and it's, of course, black holes have a large amount of gravity, you have spinning disks of material around the supermassive black hole. And they are moving at speeds close to the speed of light. And so there's a lot of friction, there's a lot of energy that that little disk emits. And so these things are extremely bright. So you can see them like to the ends of the universe practically. They are trillions of times as luminous as the sun. So we can sort of use those objects as beacons to light the material that's between the quasar that's so far away and us. So we use what's called spectroscopy, which basically spreads the quasar light into its different colors. It's like prism where you see the colors of the rainbow. But if you look at it in detail, you can see signatures of the gas, like hydrogen, helium, oxygen, and so on, that are in objects between the quasar and us. So it's as if you're using a flashlight to look through the universe. And so that gives us some idea of what the gas in the universe is like and how it changed from way back when to now.
That's
Yeah. Um, and I was just telling you a little while ago that I use data from the Hubble Space Telescope to do this work. And of course, the Hubble is above the Earth's atmosphere. And so it's not limited by the blurring of the atmosphere and so on. So you can get very sharp images and very detailed images and spectra as well of objects. So that's where I got all the data. And the other part is, these quasars, which I mentioned, they are, like I said, extremely energetic things. And so what powers the quasar is something that people are very interested and excited about. So they want to know, like, what kinds of clouds exist around the black hole, which are pretty close in, actually. They're about the solar system size objects. And they move, like I said, at, a tenth to half the speed of light. And so what are these objects like? What are these clouds like? What are their characteristics? And so for that, we had a program to look at one particular object that's like 2 billion light years away. And so that was a project that I'm currently working on. We still don't have all the results yet. So it's an exciting project to kind of peer into the very centers of these galaxies, which we call quasars.
That's interesting. I think I'm always interested in hearing about people's research, and I think a lot of people think, space is just this fantastical, thing that we just don't fully understand yet. So thank you for sharing that. I think that's
of course. Yeah.
Now, taking a step back to your own education, and obviously now as an educator yourself, I'm sure you value STEM education.
Absolutely, yeah.
But how would you say that your STEM education prepared you for your career and ultimately for your role now?
So I think growing up, it was never a question to me as to whether I could do STEM. I think a lot of kids now think that, it's too hard, I can't get into it. But the environment that I grew up in, like I mentioned, was a very sciencey sort of environment. So it wasn't a question for me. But I do understand, how kids can be discouraged, especially girls can be discouraged from taking science courses or moving into STEM fields. And I had teachers who were women throughout my career. I had, my mom was an educator. She taught primary school, and she taught science classes as well as English classes and so on. And so for me personally, it was not a hurdle. Okay. And coming to Pittsburgh and talking to middle school students here and high school students as well, I felt the need for there to be more emphasis in STEM education, more emphasis in role models for girls, so that they can, get rid of this notion that STEM is too hard, or they can't do it, or math is too hard. Girls have enormous aptitude for science and math. There's no question about that, just as much as boys do. And so I think it's just a question of getting used to the idea that anybody who's interested in math and science and who finds an ability early on can continue along that path.
That's a great message. Do you remember if there was any certain moment or experience that really sparked your passion for science?
That's a good question. So there was an older girl in my neighborhood who who sort of started a science club, an astronomy club. She was many years older than me. And, that of course piqued my interest. Like I said, I've always been interested in nature. And we used to go out early in the morning, looking for birds, bird watching, basically looking at blue jays and, cardinals and seabirds. I used to live sort of by the Arabian Sea. So right on, on the coast. It was a rocky beach, so there was no beach there, but still you could see all kinds of seabirds, right? So we used to go out early in the morning. I mean, when you're like 12, 13, to wake up early in the morning and go out bird watching was novel at the time. And at night, we would stay up at night and look at the constellations. And so I think while I already had an interest because I used to read a lot, this she was an older sister of a friend, and like I think she probably put this by putting the science club together. She got a lot of us interested in science. Um, so I would say that was a trigger for me in a sense. That, yeah, we could learn science in any which form we wanted to. Yeah.
That's awesome. I love that. I love especially, really young people who are just, at the time driven by fun and curiosity. And
Yeah.
then that builds into something more for them.
Yeah,
So that's
it's not a chore. Like if you start learning about it in school with the textbook, it might become a chore, right? That you have to complete, and then you get put off by it. But if you, at the same time, start exploring the world around you, whether it's reading, whether it's going to the library, whether it's now going online and looking and searching for topics that interest you, or talking to people who are already in those fields. There are just so many avenues for kids to follow these days that it's an exciting time to be a kid, I think.
absolutely.
Yeah.
Now, thinking of those kids, would you have any advice that you would give to a young person who is underrepresented in STEM, and interested in pursuing a similar career as you?
Sure. Yeah, I mean, I think the 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 most important thing is to believe in yourself. That if you're interested in something, then you can follow it with all the rigor and fun that it is for you. So once you understand that yes, this is possible for me, right? Then you can go forward and try to grab people, information, about what you're interested in. And don't let people tell you you can't do this, or you're not good at it, or there's no future for you in this. I think those kinds of discouraging sort of remarks that people sometimes throw at you can be can set you back. But just believe in yourself, right? And if you want to know, okay, so if I'm interested in astronomy, what is it that I have to do? I'm an 8th grader, right? I'm just going to go into high school. How can I get to that point where I'm actually going to be a researcher in astronomy or a researcher in chemistry? Pick any science topic. So around the time you're into high school, right, you should take the math classes that are being offered at school. I think math is the language with which science moves forward, right? So math is like short form. It's an abbreviation for things that are happening around you, right? So you can say a long sentence in words like, oh, I have 10 bags of apples. Each bag has 3 apples. How many apples do I have? And I can, so write that out in a long sentence. Or I could just say 10 times 3 is 30, and then I'm done, right? So mathematics is a language with which science is conducted, explained, researched, and all of that. So math is really the core of science. And if you enjoy things like puzzles and numbers, and you will have fun with math. And so no matter what people around you are telling you, take the math classes, right? Take chemistry in high school, take physics, take biology. And that, if you are of that scientific mind, that will help you focus on what science that interests you, right? And then, and don't stop taking those classes when you get to, your junior year, senior year. That will open up opportunities for you in college to explore these topics. And I'll tell you one thing. Professors in college are very excited to encourage students who are freshmen, like who are just coming into college, to try to give them the opportunity to explore their subject. Say, oh, physics is great, you should take physics. Or if you're a chemistry professor, oh, it's great, you should take chemistry. We're going to teach you X, Y, and Z. So reach out to them. reach out to college professors, even as a high school student, and say, I'm interested in this. Is this something that I should pursue? So keep that dialogue open. That's very helpful too.
Mhm.
Yeah, sorry, that was a long-winded answer.
No, I love it.
Yeah.
And kind of speaking of, reaching out to people and making connections, I'd love if you could talk a bit about mentorship and how, if there's been anyone that's inspired or mentored you, or if you kind of continue that track of being a mentor yourself.
Yeah, sure. I wouldn't pick any one person who has mentored me in, in high school or college. It was, my teachers uh, were all pretty great. I mean, I've had people have encouraged me to, to stick around doing research, and so for all, of course, I have a daughter, right? And so when she was really young, when she was born, uh, I was torn because I wanted to spend all my time with her, of course, but I also had a research career. And the person who I was working with at the time encouraged me to take my time and, and take care of her as well as, do as much research as I could. That was very important to me because I used that time, the time that I had to focus on research. I focused on it. We had some papers that we got published and so on. And so that helped me a lot at that time of my life. But that was, much later. As for mentoring students, so over my career as a uh, as a professor and a teacher here at Pitt, I've mentored many graduate as well as undergrad students. And I think it is very important. For one thing, me being a woman professor in a science field, just me being in front of a classroom or teaching a class that's filled with men and women, it it sort of removes that barrier that some people think of a science teacher is can only be a man, right? Just me being there, like settles it into their mind that it's normal. It's normal for a woman to be a STEM professor or a STEM researcher. And as for mentoring, when students come to me, I talk to them, advise them. I've had many undergraduate women students who I'm still in contact with. We just had a call the other day with three of my students from and they're married, they have children, and so it's a process that goes on for a large part of your life. It never ends. And keeping those contacts is also very important. Nurturing students to achieve their goals, if even in the STEM field, right? We can say that now, but I think that's really important.
Yeah, I think having that support as you're building your career is so important.
Yeah.
But I'd also imagine that being a mentor yourself is like a fulfilling
Oh, absolutely.
role to take.
Absolutely, yeah. I mean, there's nothing more fulfilling and satisfying to know that students you have taught have taken a little bit of that and used it in their own lives to move forward. I get emails from past students who are not STEM kids. I mean, they're business students or chemistry majors, and they still send me things astronomy related. Hey, Dr. Rao, did you see this? Here's an interesting article I found. Or, hey, I saw the eclipse in 2017. Here's a picture I took. It's very gratifying.
That's awesome.
Yeah.
And you touched on this a little bit, but it kind of leads into my next question. How important is representation in science? I know you talked about, being a female professor in a STEM field, and that kind of helps others recognize that, you can look like or be anything.
Exactly.
Yeah. So
But I think it's in today's climate, it is very important for minority students to feel like they fit in. At Pitt itself, we are taking, the extra effort to try to attract minority students. There are some fantastic students who come out of high school, minority students, and it's important for us to encourage them to do more than, and to go to university and to, get into grad school and follow their dreams. And so I think in today's climate, it's very important for us to make the extra effort to attract students of of color, of all gender types, of all walks of life, so that the mix of students and the population that is going to be in the workforce is as diverse as the population as a whole. I think it's very important and to have mentors and role models in those areas is important. So I'm a minority in terms of my sort of race, right? I'm Indian, was born Indian, and I'm a woman. So I fit into two minority categories, and I think I have made it to a point where my career is what I wanted it to be. So it is possible.
That's amazing. Thank you for sharing that and your story. I think that's all the questions that we have. Do you have any final words of wisdom or advice for the people watching today?
Yeah, I mean, I would summarize everything that I said, and being a woman in STEM is exciting, it's fulfilling, and you can do it. Right? So that is the key. If you have an interest in science, if you're excited about medicine, if you're excited about helping and curing people disease, if you're excited about learning more about the universe, if you're more excited about learning about how small atoms are, how do atoms behave, how do things inside atoms behave, that falls under the category of particle physics, and they're doing some amazing work, right? Or if you're interested in creating new materials that people can use technology wise, all of these these fields that are open to you are things that you can pursue. And it's an exciting time to be a student because of all of this that's available. And don't worry about what other people say. Don't worry about how you look. Don't worry about your inner feelings, right? You have a goal, go for it. Right? And use all the help you can get for it as well.
Absolutely. That is incredible advice. Thank you so much for sharing about your career, your advice for students, and for joining us today. This was a great conversation, and I learned a lot, and I'm sure a lot of the people watching today did as well.
It's wonderful. I really enjoyed talking to you.
Thank you. I enjoyed it too. I'm just going to give a quick plug for next week's speaker. So we hope everyone watching today will join us next week for a conversation with Angela Capelli, a pediatric oncology and bone marrow transplant nurse. We'll talk to her next Wednesday, September 16th at 11 a.m. right here again on Facebook Live. All the details are on our website, carnegiesciencecenter.org. Thanks for watching.
Bye-bye.